Hello all, in this video I will be teaching about solids, and the topics I will be covering under solids will be about unit cell, about crystal system, about close packing as well as about packing fraction. So what is crystal lattice? It is nothing but the arrangement of atoms or molecules or ions of a crystal in the form of space lattice. Here you can imagine a cube, and at the 8 corners of a cube will be placed by 8 spherical bodies, and this entire arrangement will give you a crystal lattice. Now what is unit cell? A unit cell will be the smallest geometrical portion of a crystal lattice that can represent the whole characteristics of the whole crystal. For example, you can take rock salt. Okay, the smallest portion of the rock salt, which gives you all the characteristics, all the properties of the rock salt, of the entire crystal system of a rock salt, can be defined as a unit cell. Now what is lattice points? As I told you, in the crystal lattice at the 8 corners you can place 8 spherical bodies. The 8 corners or the 8 points where you will place the spherical bodies, those points are referred to as the lattice points. As it is here, the whole diagram will be a crystal lattice, wherein the blue shaded cube will be your unit cell, wherein the red spots everywhere, the whole cube, okay, those gives you the lattice points. Here is a similar diagram. Now I have explained you about unit cell. Let's go to the types of unit cell. There is face centered, body centered, end centered as well as simple unit cell. Now how is face centered? Here you will be having 8 atoms at the 8 corners. Okay, along with it you will be having, okay, now tell me, how many faces does a cube have? Yes, there are 6 faces. So along with the 8 atoms in the corners, there will be 6 atoms in the faces. Okay, so how is it arranged? There will be 8 corners in the, there will be 8 atoms in the corners, as well as there will be 6 atoms on the faces of a cube. Next, body centered. Here similarly there will be 8 atoms in the corner, and there will be a single body, a single atom in the center, which will be touching to all the 8 corners. Okay, next will be the end centered, where again the same goes here too, wherein the 8 corners will be in the, the 8 atoms will be occupied by 8 corners. Along with it there will be 2 atoms which will be placed directly opposite, okay, on the 2 faces. Okay, here it is called end center. So you can imagine a line, okay, a straight line, and it for example point A and point B at the 2 ends. So these 2 ends will be for example, you can imagine there these 2 ends as 2 particles, okay, or as 2 atoms. So this, which is placed exactly at the 2 faces, which is directly opposite, okay, henceforth it is called as end centered, which is placed directly opposite at the 2 faces, just push towards the end, henceforth it is called as end centered. Now what is simple unit cell? You can just imagine, for example, you can see this diagram of body centered. You can just imagine this, you just cancel out this body centered atom, okay, and you can get only 8 corners along with these 8 atoms settled, and that gives you a simple unit cell. Next, let's learn about the composition of these atoms which are present on these unit cells. So the first diagram, this is about the simple unit cell. As I told you, there are only 8 atoms. Okay, there are only 8 spheres in the corners. So each sphere can contribute only 1/8 of its corners. Okay, which means one sphere in the corner can only give 1/8 of its contribution. The whole sphere does not contribute for a unit cell. Only 1/8 of its portion can contribute to give a unit cell. So 1/8 of the portion of one spherical body, which is multiplied to 8 corners, right? So this can totally give you one whole atom. Next, to the body center, the same applies here. The 8 corners will be giving 1/8 of the portion, okay, 1/8 of the contribution, wherein the central atom can give you one whole portion, one whole contribution. As I told you before, this will be touching all the 8 corners. Henceforth, it is totally one whole atom. There are no halves, there are no quarters. Okay, so this gives you into one whole atom. Next, in face center, here all the 8 corners, as it is said before, it is 1/8 of the contribution. But at the faces, the atom in one face can only give half of its contribution. It cannot give half, nor 1/8, nor quarter. It can give only half of the contribution. So how many faces are there? There are 6 faces. So how many spherical bodies are acting in faces? There are 6 spherical bodies. So how is your contribution? Half into 6. Next, here, as I explain all this, I have made into table wherein simple cubic can give you the corner of 1/8 into 8 atoms. Okay, there is no face here, there is no center here. So 8 into 1/8, these two gets cancelled and 1 results. Okay, next, in face centered, here this 8 into 1/8 applies to all the corners, all kinds of unit cell. But the difference will come in place with the face and the center. In face there are 6 faces. So how much is the contribution? Half. So 6 into half will give 3. So if this is 1 and this is 3, 1 plus 3 will be 4. Next, with the body centered, this body centered again, 8 into 1/8 will be 1. Center, only one atom is there, right? This one atom can lead just 1. There is nothing to be multiplied because the contribution is one whole atom. So it is 1. So 1 here and 1 here. 1 plus 1, 2. In the end centered, so here 8 corners, and an end centered here, just imagine this face centered cubic cell, the last portion, these two. Okay, this is not there, all these are cancelled out. Okay, only the top and the down, only these two are there. So in face centered it is half. It is the same, but these atoms present on all the faces is just cancelled. There is the only difference. So half into 2, this one and this one, half into 2, which will lead to 1. So here 1 and this 1, 1 plus 1 giving rise to 2. Now close packing. So there are 2 types of close packing. Close packing is nothing but the arrangement of these spherical bodies. Okay, very closely packed they are. Henceforth it is called as close packing. There are 2 types in close packing, which is 1 dimension and 2 dimension. So 1 dimension, you can imagine the tennis balls which are arranged in a horizontal manner, just like you stand in your assembly. So it's just placed in a horizontal manner, one behind the other. So these each will be touching to the 2 partners, right? So when you place in that form, you get a 1-dimensional form of close packing. So here you will be having 2 neighbors, hence the coordination number will be 2. In 2 dimension, you are going to stack it vertically as well as horizontally. Okay, so you will be placed like this. Balls, you will place it like this. Okay, So as you place it above or one above the other, you get a two-dimensional form. Okay, and this can be of two ways, which is square close packing, and the other will be hexagonal close packing. So this gives you a square close packing. You just stack one above the other. Okay. Now how many spheres is this in contact with? This one, this one, this one, and this one. Right? So when you join the centers of the neighbors of this sphere, okay, you can name this as A. So the neighbors of A, how many are there? There are 4. Now join the centers of them. You get a square, right? You get a square. Just tilt your screen to see an exact square. So you get a square there. So that's the reason why you call it as square close packing. And you can see these pink portions in between, right? So those are called as voids. Okay, and these are also called as AA packing. AAA packing. Okay, why is it called AA packing? Because these are named as AAA. All are similar to one another. Okay, all the spheres are similar. All the rows are similar. I'm sorry. All the rows which are placed will be similar. It will be placed at the exact position. If this row is placed, the second row will be placed at the exact position of the first, and the third row will be placed at the exact position of the first as well as the second. Henceforth, they are called as AAA packing. The next will be hexagonal close packing. These are placed, the first row after placing, the second row will be placed in between the voids. You can see here, in between the voids they are placed. Okay, hence they are called as hexagonal close packing. Here the first row, if named A, the second row will be named B, because they are not exact. The rows are not in the exact position, as they have been placed in the voids. They are not in the exact position, but the third row will be similar to the first row, hence they will be named as A. So these are called as ABA packing. Okay, ABA packing. As I told you, they will be having 4 neighbors, hence their coordination number will be 4. And here, yeah, I missed out the neighbors. Okay, the neighbors, it will be having 1 here, 2, 3, 4, 5, and 6. They will be having 6 neighbors. Hence, if you join the centers of all its neighbors, okay, this is the bride sitting in between. So if you join all its neighbors, you can get an hexagon. Okay, and henceforth it is named as hexagonal closed packing.